Hopefully this works, my first video of 2015-16 school year. So I'm going to do the problems that you asked for in class from lesson 20. So the problems you asked for, I'll do them in this order: 1, 5, 7, 9, 11. Hey, we skipped 13. Good news on that. 15, 17, no 19, no 21. We go the whole way, somehow or other, to 27. All right, so let's get going on these. I'm going to do them as quickly as possible so that you don't have to watch this forever. First one is: a kite is flying at the end of a straight string, has a length of 250 meters. The string makes an angle of 65 degrees with the ground. How high above the ground is the kite? Okay, so we have it's a little hard to draw things on here, but I do have straight lines, so that could help. We have a kite going at 65-degree angle, like that. Here's the ground, and we want to find the height. So that's kind of our triangle that we're going to form. So the angle we have here is 65 degrees. This side is the length of the string, which is 250 meters, and we need to find the height, so that's y. So we're finding the opposite. This is opposite the angle, so we're going to use sine, because sine, if you remember SOHCAHTOA, sine is opposite over hypotenuse. We're trying to find the opposite. We have the hypotenuse, so we'd say sine of 65 degrees is equal to opposite, which is y, over the hypotenuse. We're going to cross multiply, so you take sine of 65, we'll just do this all in our calculator at the end, times 250 equals y, and when you put that in your calculator, you're going to get y equals 226, round to 2 decimal points, 0.58 meters, and that's your answer. So that's using sine and cosine. In sine, cosine, tangent, using trig, but we're using specifically sine. Okay, number 5. I couldn't tell if you put 5 or 15 on the board because someone kind of erased it, so we'll do 5 and 15. So there are 12 nickels, dimes, and quarters. So nickels plus dimes plus quarters, there's 12 of them. This is just the number of coins, not the value. Their value adds up to $1.55, so a nickel is worth 5 cents, a dime's worth 10 cents, and a quarter is worth 25 cents. We're moving all the decimals over 2 because a nickel would normally be 0.05. We're moving it all over 2, so we're going to move the decimal point over 2 on the $1.55. So we get 155. And then it says the number of nickels exceeds the number of quarters by 1. So the number of nickels equals quarters plus 1. How you solve this, you can do it a couple different ways. What I'm going to do is I'm going to take these two. Since this one does not have dimes, I'm going to take the 2 right here, and I'm going to eliminate the dimes. So I'm going to multiply this one by -10 and add it to this one. So we're going to get -10n minus 10d minus 10q equals -120. Add it to this one, 5n plus 10d plus 25q equals 155. And when we add these all up, we're going to get -5n plus, the dimes are going to eliminate, plus 15q equals 35. Now I'm going to go here and I'm going to put the n equals q plus 1, so I'm just going to put it right here where the q is, right there. So we're going to get, never mind, we're going to put it where the n is because n equals q plus 1, so we're going to get -5 times q plus 1 plus 15q, we're down to one variable in one equation, equals 35. So we get -5q minus 5. I'm just looking to see how I did this because it doesn't look like what I did, plus 15q equals 35. And we get, I'm still trying to see what I did on my paper versus what I'm doing right now. Oh, I know what I did on my paper. I divided everything here by 5. It just made it more simple. So it made it a lot simpler, but we're just going to keep going here. So we get 10q equals 40. Q equals 4. And then we just go back and get everything else. Well, if q equals 4, then n is going to equal 5. And then 4 plus 5 is 9, so that means that the dimes have to equal 3. All right, see, I told you we're going to go fairly quickly here. Okay, the next one is 7. Head over to 7. All right, these are our mixture problems that everyone loves. I do my bins, but half of you don't do bins, and I'm okay with you not using bins, even though I love my bins. Okay, this one says an alloy of copper and tin is 20% copper. How many pounds of copper must be added to 20 pounds of the alloy to get an alloy that's 50% copper? Okay, you put the quantity in the buckets, you put the percentages underneath. So you have 20 somethings, what do you have, 20 pounds of alloy, which is 20% copper. You can just drop your decimal points because we're moving everybody over 2. We don't know how much copper to add, but we do know that copper is 100% copper. This is 20% copper right here. We're adding 100% copper to get an alloy that's 50% copper. How much is going to be in the bin? Well, it's going to be this amount and this amount, so this is going to be x plus 20 in here. And now we just multiply. We're going to take 20 times 20, and we're going to take 100 times x equals 50 times x plus 20. And I think you can solve it from there. So you're going to end up getting x equals 12 pounds. And that's how that works. Okay, 9. I'm on a little time crunch myself, so I've got to hurry. Okay, draw the necessary reference triangles and evaluate square root of 6 square root of 2 times the cosine of 30. So first thing you have to do is make a reference triangle. We did this a lot last year, so anyone that's new, this is what we do in pre-calculus. So we draw ourselves a right triangle. This is your 30 degrees. This is your 60. All 30, 60, 90 triangles have the same ratio, which is 1 across from the 30. 2 is your hypotenuse, and the 1 across from the 60 is the square root of 3. So when you're evaluating, we're going to do 6 square root of 2 cosine of 30. So we do all our evaluations by looking at this triangle. So cosine of 30 is adjacent over hypotenuse. So I'm going to erase that because I'm going to reuse this triangle. So adjacent over, so it's 6 square root of 2. Adjacent is square root of 3 over hypotenuse. So you're going to get 2 goes into 6 3 times, 3 root 6. And 11 is the same thing. I'm going to use the same triangle, no sense drawing it again. This time we're going to evaluate 4 tangent of 60. So you go back up here. Tangent is, remember TOA, opposite over adjacent. So opposite of 60 is going to be root 3. The adjacent to 60 is going to be 1. So it's going to be 4 times root 3. That was fast. Alrighty, let's move on. 11, and then we jump to 15, 17, and 27. Let's just get a new board. Hold on until I black it. Okay, 15. This might not have been one you asked for. 15 is one of these guys, x squared plus y squared. You probably did ask for this one because these are kind of nasty. All right, solve them simultaneously. Solve this guy for y, so you get y equals 2x plus 1. Put it in right there. So we're going to get x squared plus 2x plus 1 squared equals 9. We get x squared. If we FOIL this out the mature way, you square the first number, 4x squared. Multiply these two together, 2x, and take it times 2, plus 4x. Square the last guy equals 9. Quadratic, set it equal to 0. 5x squared plus 4x. I don't know where I got that. 4x minus 8 equals 0. It's not factorable, so you have to use the quadratic formula, which is just lovely, right? So we used to like that guy, but he's pretty bad. X equals -4 plus or minus the square root of b squared 16 minus 4 times a times c all over 2a, and I just will put you out of your misery here, and I will just pop out the answer. It's going to be -2 over 5 plus or minus 2 root 11 all over 5. So underneath here, it should have simplified to 176, and that's the same thing as 11 times 4. That's why this 2 came out like that. Okay, you have x. Now y is equal to 2x plus 1. So to get y, we're just going to substitute in that whole mess in for x. So it's going to be 2 times -2 over 5 plus or minus 2 root 11 over 5 plus 1. You have to simplify this guy. Y equals -4 fifths plus or minus 4 root 11 over 5 plus, I'm just going to change my denominator, make it 5 over 5. And so your final answer for your y is 1/5, because you have -4 fifths and 5 fifths is 1/5, plus or minus 4 root 11 over 5. So those are your answers. You actually have 4 answers. You have the plus or minus here and the plus or minus here. So that gives you 4. Okay, moving right along, 15. Oh darn, I forgot 13. Sorry about that. 13 is a proof. Maybe, yeah. Sorry, I missed that one. Okay, so here we go. We have similar triangles. Well, we have to prove that they're similar. They're just giving us, it's really hard to draw on this thing. If you thought it was hard for me to draw on the board, this is even worse. Except I could draw straight lines if I really wanted to. Yeah, maybe I will. All right, let's get some lines here. So we have a line this way. Yeah, that's much better. We have a line going down. Let me look in the book a little bit. There we go, this way. And we have the big triangle right here. And then inside it we have a smaller triangle. This side is supposed to be parallel to that one. Let's see if I can get this right. And this side is supposed to be parallel to this one. There, it's a little bit better. All right, slowing down. I got to speed up again. So we get ADFG, ADFG, and we have EB. What we're given is this side is parallel to this side, and this side is parallel to this side. And we're supposed to prove that the triangles are similar. Now the way you can tell if triangles are similar, if all the angles are congruent. If all the angles of the big triangle are congruent to all the angles of the little triangle, then you know that they're similar. So we're going to set up our little chart, such as this. So we have our statements and our reasons, and we are given that AB is parallel to DE, and we're given BC is parallel to EF. The reason I drew a line over is it's not an actual measurement, it's the segment. So that is given. If you want the measure of the segment, you don't put the line over it. All right, here we go. Here's the tricky parts. I can use color, which is fun. So we can say that this angle is congruent to this angle because these lines are parallel, so their corresponding angles are congruent. So I'll just leave the color in for fun. So we can say angle A is congruent to angle FDE. And we can also, let's get something else here, we can also say that this angle right here is congruent to this angle for the same reason. They're corresponding angles. Parallel lines cut by transversal, this would be the transversal at the top. The corresponding angles are congruent. So we can say angle DFE is congruent to angle C. And the reason that we can say that is you can just simply write corresponding angles. Corresponding angles. And I like to say are congruent. All right, we need to get the third angle congruent because in order to be similar, all three angles have to be congruent to all three angles. we can say very easily angle E is congruent to angle B. The reason why is if two angles are congruent, then third angle has to be congruent, right? If you have two angles, the third angle, if you subtract them both from 180, should be the same. So finally, we can say triangle ABC is similar, not congruent. This is a line for similar. It means all the angles are the same and all the sides proportional. D, E, F, and the reason why is if, we can say triangles are similar if all angles are congruent. Little shorthand there. Okay, 13, we did 15, we are now on 17, and then we have to do 27, and we're done. Okay, I'm gonna have to move to another whiteboard. Those took a lot of space, and I will blacken it. Okay, 17 is a formula that you have to memorize. Hopefully by the end of this book, you will have it memorized, because these problems are gonna come back and get you all the time. So you may as well just memorize it. Remember this one? This is a sum of two perfect cubes. So if it's a sum of two cubes, when you're factoring, it's going to be u plus v. Whatever this sign is, that's what this sign is. And so we're going to get u squared minus uv plus v squared. So you need to figure out u and v. U is the cube root of the first term. So 3 times 3 times 3 is 27. X times x times x is x cubed. X squared times x squared times x squared is x to the sixth, and our v would be 2p. And then you just really just plug it in. So it's going to be 3xy squared plus 2p. Probably didn't leave enough room. U times u squared would be 9x squared y to the fourth. Multiply those together, so we're going to get 6xy squared p, if you multiply those two together, and then we're going to square the last one, so it's going to be 4p squared, and that's it. These are really easy if you memorize this formula, so make sure you memorize that guy. Okay, and our final one, number 27. This is coming to be pretty short, so this is a really easy one. You just need to know the formula. So you have a circle, and in the circle you have two chords. Chords go from end to end in the circle. They're not necessarily the diameter, but they can be. In this case, it is a diameter. And the way that we can tell it's a diameter is it's going to go through the center. Diameters go through the center. So let me just put a center point on there somewhere. And they're going to tell us that this is 3, this is 7, this is 9, and this is x. So the formula says if you have two chords intersecting in a circle, the product of the segments of one chord equal the product of the segments of the other chord. So simply saying 3 times x is going to equal 3 times x equals 7 times 9, or 3x equals 63 and x equals 21. And then you have to go back and see what the question is asking for. The question is asking you to find the radius of the circle. Well, this is the diameter because it goes through the center. The diameter is equal to 24 because x is 21 plus 3 is 24. So you just divide that by 2, and so you get the radius equals 12 meters. And that's it. Homework on speed here. So, okay, so that's it for the homework for lesson 20. Email me if you have any questions.